So hope everyone will be fine. You also take care. Okay.
Yes,
So
sir. You also take care, sir.
see, yes, yes. Uh, Expansion of function. So why to study Fourier series? Okay, that we want to understand. Okay. In last unit we understood expansion of function. Hope you remember expansion of function. What we have done, we expanded the different functions. We expanded e raised to x1 plus x squared divided by 2 factorial and so on. And then we understood that it is possible to integrate e raised to x, right? It is possible to integrate e raised to x square into x dx, but it is not possible to integrate e raised to x square. Okay, not possible. And therefore, we have written this expansion of e raised to x square in terms of ascending powers of x, 1 plus x square. I am replacing x by x square, x raised to 4 by 2 factorial and so on. And then we integrated, we know how to integrate the polynomial, and we understood the use of expansion of function. This is one way. Okay. Now, say we have periodic function, right? I think everyone understand what is the meaning of periodic function is.
Yes.
Right, sin x and cos x, they are periodic function, and many of the real life different things now, they are the periodic only. Okay, days, sorry, say sunrise is a periodic function. Okay, sunset is a periodic function. Then 7 days of a week, it is periodic function. Seasons of a year, they are the periodic function. Right, all these are periodic functions. Right, so whenever we have a periodic function, and say periodic function is like this, say, let me take one example. Hope you will understand this. A particular part is repeated. Okay, so for example, this is y-axis, this is x-axis, this is origin, and this is the function defined from x equal to 0 to say x equal to 10. Again, from x equal to 10 to 20, same function is there, x equal to 20, and now so on, 20 to 30, on negative side also, minus 10 to 0, okay, and then so on. Then this is known as periodic function, right? Say the periodic function is given by y equal to f of x. So many times, in fact, in case of partial differential equation, right? Whenever we want to solve the partial differential equation, it is required to write the given function in terms of sin x and cos x. Again, why sin x and cos x? Sin x and cos x, they are the standard periodic function. Standard periodic function whose period is 2 pi. I think everyone know this. They are the
Yes.
periodic function and period is 2 pi. So our aim is to write the function f of x in terms of sin x and cos x. And this is done using the Fourier
Yes.
series. Okay. Yes.
No, no, no. Understood.
Okay. Let me continue. I think you might know the Napoleon. Napoleon is known to you, na? Napoleon is from France, na? I think he
Yes,
was
sir.
there 17th century and he
Ah, yes.
wanted to win the whole world. Okay. So Leibniz might be known to you. Leibniz is a
Yes,
mathematician
sir.
who was
Leibniz.
working. He was working with the this Napoleon and this Fourier. Na? In fact, it is Fourier. It is not Fourier. It is Fourier, French word. So Fourier, he was a friend of the Leibniz. So he was also working with the Napoleon. So Leibniz, Fourier, they were working with the Napoleon. So on the one of the expedition to win the world, the Napoleon started from the France. He won the maximum of Europe. Then he went to if you know the map of the world, then he came till the Egypt, right? He won everything, and in Egypt now he was for a long time, and I think he was out of his home for last 2 3 years, and all the soldiers, right? Uh, they were now tired, right? And then Napoleon decided that he will return to the France, and then he asked the Fourier and Leibniz to stay in the Egypt only and see towards the Egypt and take care of the Egypt. Okay, so this Fourier, he was no doubt he was for the bread and butter. He was working with the Napoleon, but he was more interested in the mathematics, physics, and science. So he started working on different concepts, and he went to the pyramids of Egypt. And there he come to know that while studying the pyramids, he come to know that somehow it is possible to write the function f of x, right? The function f of x that can be written in terms of sin x and cos x. Right, all the mathematicians at that time, they were struggling to solve the partial differential equations. Right, I think differential equations known to you, right? D square y divided by dx square plus x dy by dx plus e raised to xy equal to tan inverse x. This is second order differential equation, but this is ordinary differential equation, ODE. Something partial is there, and the wave equation, partial wave equation is like this. We'll study this in M3. D square del square u divided
Del
by del x
square. Yes, sir.
equal to c square del square u divided by del t square. So the whole world, I'll not say whole world, many of the mathematicians and physicists, they were trying to solve this partial differential equation known as wave equation in 17th century. And they were struck at this moment. They were able to find this f of x. Some condition is there, f of x. F of x equal to summation bn sine of nx. After this, they were not able to solve the remaining part. That is, they were not able to find the value of bn. Right. So you might have understood the function f of x is written in terms of sin x and cos x. Right. Actually, cos x I not written. If I write an cos nx, then we will get the cos term. So let the time being, let me continue with this only. And then the Fourier was one who gave answer of this, and he gave the Fourier series. And this was the time when all the mathematicians and all the scientists, they will start thinking on the concept of function. What is function? Till that time, whatever definition of function we are using, it was not clear. Everyone was giving a different definition of the function. And then after around 50, 60 years, the definition of function, again, it was, I think it is given by Fourier only, and the definition of function was fixed. And the same definition we are using today also. Okay, so the Fourier series was the concept given by Fourier, which started the study of function, definition of the function, and then how we can write the given function in terms of sin x and cos x. Okay, this is the history behind it. Timing, let me continue with Fourier series. Now we want to understand different concept of the Fourier series. So we understood one, expansion of function gives the I think I forget one concept. Expansion of the function, right? Expansion of e raised to x. For this, the conditions on the function should be continuous, right? But same condition is not there on f of x. If you want to find the Fourier series expansion, the function f of x may be discontinuous also. So finite number of discontinuities are allowed. Understand what I'm saying? The function f of x is not continuous, right? 2-3 conditions are there. I'll tell you what the conditions are. So the function may be discontinuous at few points, known as finite number of discontinuity. They are allowed. And then if function is periodic, then we can write function f of x in terms of sin x and cos x, known as Fourier series expansion. Okay, let me continue. Now we start with the first concept, very important concept. The concept may be asked in exam. Okay, so let me continue. Let me go to the next page. Now you have to write with me. Right. Yes, periodic function. We are starting with the first concept. Periodic function. A function f of x is said to be periodic of period p if f of x equal to f of x plus np. What the n is? N belongs to set of natural numbers, right? This set of numbers, mathematically it is written like this. 2 lines are written. Okay, this is set of real numbers. Hope you know all these things. Real numbers. This is the set of
Rational.
very good. Rational numbers, natural numbers. and so on. This is a set of complex numbers. You might know all these things very well. These are the notations for the set. Okay, so let me go to the periodic function. So a function f of x is said to be periodic of the period p if f of x equal to f of x plus np, and we know the examples very well. For example, again, for those who don't remember the concept or till not understood the concept is like this. Say we have sine of say pi by 6, sine of 30 degree. What is sine of 30 degree? Yes, sine of 30 degree?
Half.
Right?
Half.
Yes.
Half.
And this is x-axis. This is y-axis. And say sine 30 is somewhere here. Theta equal to 30 degree. Suppose I complete one cycle. One cycle is 2 pi, isn't it? I start from the x-axis and I complete one cycle. So it is 2 pi, and again I move 30 degrees. So 2 pi plus 30 degrees. So I am again moving at 30 degree.
Same
And what
value.
will be its value? 1
Same.
upon 2.
1 upon
Okay. Then if I complete the 2 cycles, that is 4 pi and then 30 degree. Okay. So this is one cycle. And then again I completed one more cycle and again 30 degrees. So again it will be equal to 1.
1 by 2.
So
One.
conclusion is that you might have understood sine of pi by 6. Better I'll write it here. Sine of pi by 6, that is equal to sine of see, I am multiplying 2 pi by some number, 2 pi plus pi by 6. Right? Now I can take n equal to 1, I'll get 2 pi. N equal to 2, I'll get 4 pi. N equal to 3, I'll get 6 pi and so on. That is sine x equal to, right? If I want to generalize, it is sine of x plus n into 2 pi. Right? Where n is any natural number. Okay. So what is conclusion? Period is 2 pi. Okay. Write this. Or you just write period of the sine x is 2 pi. If you know all these things, no need to write them again and again. Yes, any other example of periodic function?
Sir,
So cos x pi.
Yes,
Cos-
sine,
Okay.
absolutely. Sine x and cos x are periodic functions of period 2 pi. Hey, what about tan theta? Is it periodic?
Pi. Sir, it
Pi.
is not a periodic function. Tan theta cos theta, it is not a periodic function.
Tan theta is?
Not a periodic function, sir.
Okay. Is it so? Is tan theta is not a
No.
periodic function?
So it
It
is
is
periodic, but
periodic.
it is somewhat discontinuous.
Discontinuity is we don't have to do anything with the discontinuity. No? Discontinuity or continuity, this is different function. Right? Boundedness, unbounded, this is also different function. Right? And periodicity is a different concept. Right? So if same value is repeated again and again, that is periodic. It may be discontinuous in
Yes,
between,
sir.
no any problem. Okay, so tan x is a periodic function.
Yes, sir.
Period is pi.
Yes, sir.
Okay, period is pi. You check it. You check in this way. Tan x, whether it is equal to tan of x plus n pi. That's it. You take any value of n, any value of x, and see whether it is true or not. That's it. Getting everyone? So it is periodic function. No doubt, anywhere in the this Fourier series now we are not using the concept of tan.
Yes,
Okay, then
sir.
write next example. We have a graph like this. Before some time I have drawn it. So say x equal to 0, x equal to 10, x equal to 20, x equal to 30. Yes, what is the period? Period is equal to 10. Getting everyone?
Yes, sir. 10.
Yes, sir.
Yes, let me go to the next page and a few more concepts we want to understand about the periodicity. And the question is expected in probably it will have online exam, expected in the online exam on the periodic function. Can I change the page?
Yes,
Yes,
sir.
sir.
Let
Yes,
me
sir.
change
Yes, sir.
it. Okay. So next example, fourth example. See, we have x-axis. This is y-axis. Okay, this is origin, and I have a function like this. Here we have say 3, then 6, then 9, then 12, and so on. Is it periodic function? Is it periodic function?
No,
Yes.
no. Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
because it is
See,
repeating
I'm
the
not
same
asking
value.
you whether it is continuous or not. I'm asking whether it is
Yes, sir,
periodic or
periodic.
not.
Yes,
See,
sir. Yes, sir.
and what the period is?
6.
No,
3.
It is
one,
not 3, huh? Since see,
one.
part of
3.
the function between this part 0 to 6, it is repeated again and again, na? Okay, so
Yes,
period
sir.
is 6, period is not 3. If period is 3, we should have this line over here, which we don't have, isn't it? Right?
Yes, sir.
Remove
Yes,
Ah,
sir.
that. Huh?
Okay, sir.
Remove this. Please remove this. Okay, I think you understood the concept.
yes.
Okay, now say I have y equal to sine 2x. Yes, what the period is?
Sir,
Very
Pi.
good. Go ahead.
pi.
We'll check that. Okay. So x equal to 0. What is sine of 0? 0. X equal to pi by 4. So it is sine pi by 2. 1. Okay. Then x equal to pi by 2.
Yes,
Sine
sir.
of pi. 0. Then
0.
3 pi by 4. That is minus 1.
Yes,
Then
sir.
pi.
Yes,
That is
sir.
sine of 2 pi. 0. And now so
0.
on. So the graph is like this. See. This is the x-axis. This is y-axis. Say this is x equal to, here it is, pi. This is pi by 2. Okay. This is 2 pi. And now so on. This is origin. Okay. And the graph of a function is like this. Start here. Pi by 2 it is 0. Then it is like this. Then again it will start like this. Whereas if we take, this is for y equal to sine 2x. And if we draw the graph of y equal to sine x, it will be like this. X-axis, y-axis, this is 2 pi. It's so like this. Graph is like this. And now so on. Okay. So what is period here? Yes. Period is pi. What is
Pi.
period here?
Pi, sir.
2 pi.
Period
2 pi.
is 2
pi.
pi. Okay. So let me generalize this. Let me generalize this. Okay. Right now, very important statement. No. If period of f of x is p, then period of f of ax is what? P by a, right? Multiplication by a is converted into division by a. For example, we'll write few examples. So I'm writing a function and you have to tell me what the period is. Okay, let me take different examples, important examples. Sine x. What is period of sine x? Very well known to us, 2 pi.
2 pi.
Okay, cos x, 2 pi, known to us. Okay, then suppose it is sine of 3x. What is the period? 2 pi divided
2 pi by
by
3.
3.
3.
2 pi by 3.
Yes, divided by 3. Okay. Then say cos of 4x. What is the period? 2 pi divided by
2 pi by
4.
4.
That is pi divided by 2.
2.
Yes. Then suppose it is sine of x by 2. Yes. What is period? 2 into 2 pi. Isn't it? That is 4 pi.
4 pi. 4 pi.
Right. Then if it is tan of 3x, what is the period? Period of tan x is pi. So
Pi by
pi
3.
divided by
3.
3.
3.
And so on. Hope you understood the concept. Is it clear? Take one more example.
Yes, sir.
Sine of 3x by 4. Yes. What is the period? So 2 pi, basic period. And then take 4 by 3.
4. Yes, sir.
Right. Take reciprocal
5
of
by
this,
3.
whatever
5 by
multiple
3.
is. Take reciprocal of the multiple. Ax p by a. Is it clear? Have you understood the concept? This is all about the periodic function.
Yes, sir.
Okay, now we'll understand what the Fourier series is. We'll define the Fourier series formally, formal definition of the Fourier series. So let me change the page. Let me go to the next page, page number 5. And we have to understand integration. We should know integration very well to solve the examples on the Fourier series. So, Fourier series, definition. Correct. If a function f of x is periodic function of period 2 pi, sorry, 2L, let me start with the arbitrary period, 2L, defined in interval, say C some constant, C to C plus 2L. F of x is a periodic function of period 2L defined in the interval C to C plus 2L and satisfy Dirichlet's condition.
Dirichlet condition.
Yes. What are the Dirichlet's condition? Write them. One. F of x is finite, so it should not become infinite. And single valued. Single valued, you understand? Na? For one value of x, we should have one value of y. Single valued. And its integral exists in above interval. Second, f of x has at most finite number of discontinuities. So function is not continuous. Finite number of discontinuities. Third, f of x has at most finite number of maxima and minima. Okay. Then f of x can be represented as f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos of n pi x divided by L plus b n sine of n pi x divided, this is visible, plus
No, sir.
bn, okay, I'm writing it, sine of n pi x divided by L, where a naught, an and bn are known as
Coefficient.
Fourier coefficients, no doubt. And they are given by They are given by derivation is not part of syllabus, so I'm not taking derivation, how a naught, an and bn is obtained. So those who want to study, they can go through any reference book. Or someone can take a seminar on this.
Sir, we can write L by pi. म्हणजे आपण L च्या जागेवर पाय लिहू शकतो का आपण?
Afterwards that we are going to do. First we are understanding the general definition, and then we'll make specialization in it.
Okay, sir.
Sorry. Yes, this is the definition of Fourier series. Big definition, you have to remember it. Few concepts and formulas we have to understand, and then we'll start with the examples. Probably today, in today's lecture, we'll not able to start the examples. Okay, next. Can I change the page?
Yes, sir.
Yes, sir. No, sir. 1 minute.
Yes, sir.
First. Okay, so I'll change the page.
Yes.
Right. Formulas and concepts. Okay, right. One. Integration by parts. So we know this formula, integration of uv, u as it is, integration of v minus u dash, integration of v, right? And to choose u, use
Pilot rule.
I L A T E. Okay, I think everyone know this is inverse trigonometric function. This is logarithmic function. This is algebraic function. This is trigonometric
And
function, and this is the
Exponential.
exponential function. I think exponential function is the simplest function to be integrated.
Yes, sir.
Okay.
Yes, sir.
So the integration difficulty increases in this way. Second, right? Bernoulli's. Chain rule or Bernoulli's formula. So Bernoulli's formula like this. Say we want to integrate u phi. So it is like this: u as it is integration of v minus u dash integration of v twice plus u double times v integration thrice, and so on. Alternative plus minus sign, and then increase the derivatives of u dash, u double dash, u triple dash, u fourth derivative, and so on. Integration of v once, twice, thrice, four times, and so on. Okay, this is Bernoulli's formula. Now question is, two questions are there. When we have to use the above formula, integration by parts formula, and when we have to use the Bernoulli's rule, and how to choose the u. Okay, so we'll answer them. Above Bernoulli's formula, Bernoulli's formula is used when, yes, anyone? Derivative of one of the function. Derivative of one of the function becomes 0. Then only we can use Bernoulli's rule. And
yes.
how to choose? Select u such that its derivative become 0 earlier. Right? How to select u such that its derivative will become 0. Right? We'll go through one example since in Fourier series we have to use this formula again and again, and we don't want confusion afterwards. So let me go through one example. For example, so we want to integrate this x square sine of 3x dx. So we can solve the example by both the methods, integration by parts or Bernoulli's rule. But it is always suggested to use the Bernoulli's rule whenever it is applicable. Understand what I am saying? Whenever it is applicable. And when it is applicable, whenever derivative of one of the function become 0. Out of x square and sine 3x, whose derivative becomes 0? Of the x square. That
X
is u.
X
X square.
Absolutely. And this is the v. Okay. And the rule is like this. U as it is, integration of v minus u dash, integration of v twice, u double dash, integration of v thrice, and so on. Okay, since it is first example, let me write everything. U equal to x square. What is u dash? 2x. What is u double dash? 2. What is the third derivative? 0. Right. So
0.
these terms will become 0, right? And next few terms they will be, in fact, remaining all terms they will be equal to 0 for this example. Okay.
Yes.
Whereas v equal to sine 3x, and the integrals of sine 3x they are like this. What is integration? First integration
1 by minus 1 by 3.
minus cos
Yes.
correct, minus cos 3x divided by 3. Twice integration minus sine 3x divided by 3. Already 3 is there, so 9.
9
And thrice integration minus will be plus cos 3x
plus
divided by
3x by 27.
27. Right. Let me substitute these values, and therefore the answer will be like this. Hope you might have understood. So first term, right? So u and integration of v. Okay. So answer is I equal to this. I am writing. This I am writing. Answer equal to u. So x square and integration of the v, that is minus cos 3x divided by 3. Okay. Next term now. Let me write by green color. So this term, so u dash and integration of v twice. So it is minus sign of the formula. Okay. Then 2x and then integration twice minus sine 3x divided by 9. Okay. Next term plus. Next is plus. Okay. Let me use this.
2.
So this term u double dash, that is 2, and thrice integration, so it is 2. For few of you this might be boring, but I think that
Sir, the last one minus will come. So
last one, why?
3
No,
derivative.
minus plus.
No, sir.
Correct na? Whatever written, I think it is correct.
Yes.
Yes, sir.
So answer is minus x square cos 3x divided by 3. Okay, then minus plus 2x sine 3x divided by 9, and last term is 2 sine 3x divided by 27. And no need to write dot. This is the answer. This is the integral. Right? We are using this again and again. So if not written integral, no problem. But at least you understand what we are doing here. Okay.
Yes.
Can I go to the next page? Understood everything?
Yes.
Yes.
Yes, sir.
Sir, just a minute.
Okay. No.
Yes, sir.
No problem. Right.
Done, sir.
Okay. Sure. Next. So let me change the page. Third formula, very well known to us, but let me write it. E raised to x sine of bx dx. What is it?
Yes, sir.
E raised to x
upon a square plus b square.
Very good.
Bracket a sin bx minus b cos bx.
Yes. What is integration of sine minus na? So minus b. Cos of bx. Sorry.
Yeah.
It should be cos of bx. Then next formula. E raised to x cos of bx.
सिर्फ
So-
साइन चेंज होगा, मतलब उल्टा होगा.
हाँ,
साइन का
correct.
कॉस होगा, कॉस का साइन होगा.
Okay, and what about the sign in between?
Sign will same, minus only.
Minus will become plus. Integration of cos is plus sign, na? Therefore it is like this. Yes, remember these formulas. Okay, write them. Now you write these formulas, formula number 3 and 4. If you are not writing example, it is okay, no problem. But we have to write the formulas. Now, few concepts and formulas about the trigonometry that we have to write. Huh? So, trigonometry. Yes. So, let me start with the sine function. We know that. What we know? This is y-axis. This is x-axis. We want to find when sine theta is 0. Sine theta equal to 0 implies. So sine of 0 is 0. Sine of pi by 2 is 1. Okay. Sine of pi is 0. Sine of 3 pi by 2 is minus 1. Okay. Let me write the angles now, so that there will be no confusion. 0 degree. This is pi by 2. This is pi. And this is 3 pi by 2. Again, this will be 2 pi. This will be 3 pi. This will be 4 pi. This will be 5 pi and so on. We are interested in 0 values. Huh? Therefore, I have written these values. Okay.
And
So, in fact, you might have understood sine of 0 equal to 0. Then
0.
sine of pi equal to 0. Then sine of 3 pi equal to 0. So, in short, how we can write this? Sine of n pi equal to 0.
0.
Where
Zero.
n is any integer. Huh? In fact.
Yes.
We can consider minus 1, minus 2, minus 3 also. Yes, write this. Sine of n pi equal to 0. Then we want to find same result in case of cos also. So we want to find cos theta equal to 0. We want to find corresponding theta.
So 2n
2n
pi.
plus 1 pi by 2.
2n.
Yes, absolutely. I think many of you know it very well. So x-axis, y-axis, this is pi by 2, this is 3 pi by 2, then this is 5 pi by 2, okay, then this is 7 pi by 2, then this is 9 pi by 2, and now so on. So on. Okay, so cos of pi by 2, 0. Okay, then cos of 3 pi by 2, 0. Cos of 5 pi by 2. Now we want to generalize this equal to 0. So cos of, yes, how we can write this? Cos of
2n
2n plus 1 pi.
2n plus
2n
1
plus 1 pi by
pi by
2
2 equal to 0. Okay, or we can write in this way. So cos of 2n minus 1 pi by 2. Both of them are same only, equal to 0. Write this formula is third. Now see what I want. In previous two cases, our aim was to get sine theta and cos theta equal to 0. Now we want sine theta equal to 1, cos theta equal to 1. Okay, so sine theta equal to plus minus 1. This is required, and it is like this. Here x-axis, here y-axis, here pi by 2. I think I'm using same pen for long. Okay, then this is 3 pi by 2. Then this is 5 pi by 2. Then this is 7 pi by 2, and now so on. What is sine here? 1. Sine pi by 2 is 1. What is sine of 3 pi by 2 here? Minus 1.
Minus
Write
1.
this on next page. Can I change the page?
Yes, sir.
Yes, so it is like this. So, page is to be changed. Sine of pi by 2 equal to 1. Sine of 3 pi by 2 equal to 1. Okay, then sine of 5 pi by 2 equal to 1. Minus 1, sorry. Sine of 7 pi by 2 equal to minus 1. And now so on. So, say I want to write this sine of 2n plus 1 pi by 2. Yes, what should be written here?
1.
Take,
2n plus
for
1 pi
example,
by
if you don't understand, you take n equal to 1 here. So it is sine of 3 pi by 2. What is sine of 3 pi by 2? Minus 1. Take n equal to 2. So sine of 5 pi by 2. What is sine of 5 pi by 2? 1. Okay. So can we write like this? Minus 1 raised to 1. Can we write like this? Minus 1 raised to 2.
Yes, sir.
right? So
Minus
that is
raised
minus 1 raised to n.
n.
Okay, this is the formula. Or we can write in this way also, or sine of 2n minus 1 pi by 2. Yes, what it will be? Minus 1 raised to n minus 1. You check this. Okay, fourth formula now. Now we want cos theta equal to
1.
plus
The
minus 1.
screen is on.
Alright.
It is disconnected.
Okay, just 1 minute. Give me 1 minute only. So it is better to start on the new page. So we want cos theta equal to plus minus 1. Okay, x axis, y axis. This is 0 degree, this is pi, this is 2 pi, this is 3 pi, and so on. Okay, and we know that cos theta, cos 0 equal to 1 here, and cos of pi equal to minus 1 here. Okay, so cos of 0, 1, cos of pi, minus 1, cos of 2 pi, 1, cos of 3 pi, minus 1, and so on. So cos of n pi. What is cos of n pi? Minus 1 raised to n. Okay, very important. Remember this formula also. Then add on next. Okay, next concept. All right. 6 even function. Already we have written this, huh? Yes. What is even function? Right in
F of
short.
x is equal to f of
F of x is even function if one midpoint is x equal to 0. The interval in which the function is defined, the midpoint should be x equal to 0. Why it is required, we'll understand. Huh? Today we'll understand it. Then that next. Examples also, we know the examples. We studied all these things in previous lecture, previous unit. So note 1 examples. Tell me examples.
Sir, f of x is equal to
Cos x,
of
then
X.
sec x. Usually it is not required. Then x square, x raised to 4, x raised to 6, even power terms. Okay. Then
Modular.
f of x equal to some constant number. Okay. Fourth, f of x equal to mod x. Right. We know all these things very well. Okay. Then what about the graph? Graph. Even functions are
Symmetric about
Symmetric about y-axis.
very good. Symmetric about y axis, and it is always better to keep one example in front of you. Okay, so for example, y equal to x square.
X square.
This is a parabola. Parabola is like this, right? Which is symmetric about the y axis. Okay. Then now we have to understand the integral property also. Integral property. If f of x is even, then tell me what is integration of f of x from minus a to plus a?
0. Sorry.
Yes,
My
everyone
f
remember
is
this. It is 2
Two
times
times. 2 times.
integration of f of
0
x.
to a f
A,
of x
If
dx.
function is even and
Very
if function
good.
is odd, 0.
Zero.
Very good. Very good. Integral property. Very important to remember this. Hope you are writing all these things. Okay. Next. Let me take few examples and you have to tell me. Acha, first I'll go through the few more examples and then we'll go to the order function. How much time we have? 3 minutes only. I have to take the attendance. Okay. First I'll take the attendance and then you can go to the next lecture. 1,
Present.
2, 64 are there. So how many are absent? 2, 3 are absent. Okay. So instead of taking everyone's attendance, it will be better to take attendance in this way. Let me take the attendance. So roll number 13,
Present, sir.
9, roll number 9, 9, absent,
No present, sir.
9 is present. Okay. Then 14,
Present, sir.
13, 13,
Present, sir.
21, 21, 21 absent, 25, 25. Acha, they have left the college. 21, 25, 26, 26 absent,
Sir, in
26 is
chat,
present. Present. Okay.
yes.
35.
Sir, present, sir. 26.
Okay. 35,
Present, sir.
37,
Present, sir.
45,
Present, sir.
46,
Present, sir.
then 51, 51. Acha, I think he has also left. Okay. Then 56, 56, 56 is absent. Okay. Then 61, 61. Remaining all are present. You don't have to write it in chat box. You don't afraid about all these things. Okay. 61, 61 absent. 65, 65.
Sir, in
Ah,
chat,
Present, sir. Present, sir.
65 is present. Who
Yes,
is
sir. Present, sir.
So 56 and 61, they are absent, isn't it? Remaining all are present. 18 is present. Everyone is present. Right? Actually, 66 is the strength and
Sir, 26.
all remaining all, no? Except 56 and 61, remaining all are present. I wanted to find 2 students only. So why to take attendance of everyone? Okay. So thank you.
okay, sir.
We'll continue.
Thank
We
you,
have
sir.
one more lecture. Thank you. Bye bye. You can leave.
Thank you, sir.
Thank you, sir.
Thank you, sir. Bye, sir.
Thank you, sir.
Thank you, sir.